Alright, you guys, so let's go ahead and get started on example 5 here. Now, if you guys take a look at example 5, we do have expressions that are multivariable, which means that we have more than one variable involved in the expressions here. So I do want to go ahead and start off whenever you are trying to simplify a rational expression, first thing you have to do here is factor. So our goal is to basically factor both numerator and denominator to determine what can be eliminated. So I'm going to go ahead and start off with the first expression here that we have. And I do want to go ahead and note on -5, and in this case, we would consider this our coefficient, and 4n squared would be considered the constant. So both of these numbers that are highlighted is what we're going to base our factors. So we're basically looking for two numbers that would multiply to give us a positive 4n squared, but will also add up to -5n. Now, since we have this being a positive, we could either have two positive factors or two negative factors. And based on our middle term in this case, since that's negative, that's going to be based off a negative factors. So let's go ahead and rewrite this. Now, those negative factors in this case would be a -4n and a 1n, or -1n. So I'll go ahead and rewrite this. We have x minus a 4n times x minus an n, or I could do this x minus a -1 or -1n, but the 1 isn't necessary. So then let's go ahead and move on to the bottom. And in this case, we have a -3n plus 3x, and I'm going to go ahead and factor out a 3. And we are left with the -n plus an x. Moving on to the next one, we have nx squared plus 16n cubed. And the only thing that we could factor from those two would be one of the n's. And we're left with x squared plus 16n squared. And all of this is over 12n cubed. So let's go ahead and take a look here what we could probably eliminate. Now on these ones, I do see that we have an n and n cubed here, so I could actually eliminate the top one, and this one would just become squared. We subtract one of the exponents. And if you guys take a look at this here, we do have two binomials that are the same. In this case, this is x minus an n and -n plus an x. If I switch the order of these two, we could have an x minus an n. So both of these are out. So then let's go ahead and move on. And here we already canceled the common factors. So then we're left with x minus a 4n times x squared plus 16n squared all over 3 times 12n squared. So then from here, we can go ahead and just multiply. I could actually multiply the two binomials. That would just give me a bigger polynomial in this case. So I'll go ahead and leave those alone, but I'll go ahead and multiply my denominator. So we have x minus a 4n squared, not squared, sorry, times x squared plus 16n squared all over 36 n squared. And this here would be our